we're going to take a look at this mall problem to help us learn the skill of adding and subtracting matrices. So matrices are a way of organizing data or information in a certain way. So it's just another tool we have to help organize certain things. So if we look at this part 1, they have some numbers for a couple of different malls and shipments of shirts, some small, mediums, and larges. All of this information right here can be organized in a better way or a different way. So if we look for November shipment, we can break those exact same numbers into this. And the way we label it are we have rows and columns. And then we want even more specific, breaking up the mall 1, mall 2, the small, medium, large, in order to organize each of those different rows in the different columns. This particular matrix is said to be a 2 by 3, meaning 2 rows, 3 columns. You always are going to say the rows first and then the columns. So when we get to these 4 problems, pause me for a second and label what those dimensions will be. Remember, you do rows first, columns second. Go ahead and pause. Hopefully when you did these, you found out that this first one was a 3 by 1. This one is a 3 by 2. This one's a 2 by 2. And then this one's a 3 by 4. You're always doing the rows first, columns second. If we take a look at a problem here, there's the numbers for a November shipment of shirts and then December shipment. It says to write a matrix equation which describes the total shipment. Well, if we had 20 smalls at mall 1 and 11 smalls at mall 2 or mall 1 in December, when we want to see the total shipment, we add those together. If we want to know all of the mall mediums, we would add the November shipment plus the December shipment. So what our matrix equation would actually look like is taking that whole thing plus this whole thing and total it up. So if we do actually add those, we're taking this one plus this one, taking this one with that one, over here and over here. Same idea. Just keep matching them up and you should be getting these numbers. Well, how does our matrix for the total compare to the November and December matrices? Well, this one we had said was a 2 by 3. This one was a 2 by 3. When we added them together, what did it become? A 2 by 3. So they actually have to be the same size in order to add them. So adding 2 matrices, they have to be the same dimension or same size. So take a look at these 3. If possible, add them together. If not, just write not possible. Go ahead and pause me and we'll check the answers in a second. With A, you should be getting 16, 12, negative 8, and 4. With B, that's not possible. If you look at the dimensions, this was a 2 by 3, this was a 2 by 2, so they're not the same, so you can't add them. Little trick with C, was actually a minus sign. So instead of adding the two matrices, you were subtracting. So that minus does get distributed to each of them. And if you do that, you should get 12, negative 13, 5, 0, 5, and positive 13. And when you're reading the matrices, you go from left to right and then up, down. So just like you're reading a page, words on a page. Let's take a look at problem 2. Same numbers, same sales, November, December, but they're saying in January, they received twice the amount of shirts as they did in December. So if you're shipping off twice as many, what operation are you thinking you do? You multiply. And it's actually called scalar multiplication. And in order to do scalar multiplication, you're just actually distributing that multiplier to each of the terms in the matrix. So if we're doubling December, we can write 2, and then we have 11, 28. So I'm just repeating the December sales. And when that gets distributed to each of them, we should get 22, 56, 28, 34, 54, and 24. Go ahead and try A and B right there. Pause and I'll give the answers. So if you distribute that 3, you should get negative 3, 9, 6, 15, negative 12, negative 9. Taking a look at B, look at it almost as two separate ones. This 4 is being distributed by each of those, and then it's subtracting this one. So it's like a minus 3 being distributed to each of those. So the one on the left, you initially get negative 4, 20, negative 8, and 0. And then the one on the right, you're getting a minus 9, a 6, a negative 3, and a 12. So now, because those are both the same dimensions, a 2 by 2 and a 2 by 2, add those together. Or if you didn't distribute the minus 3 and you just did a 3, you'd be subtracting your results. And you should be getting negative 13, 26, negative 11, and 12. Let's go ahead and take a look at part 2. Part 2 has the same numbers, same problem that we've been dealing with, but now let's actually take a look at some of the values in them and see if we can pick apart what they mean. So problem number 3. Describe what the 20 and the 3 mean in the above matrices. So let's find the 20. There it is. And we're kind of thinking, okay, it's this column, this row, and that matrix. So if we're putting all of those together, the 20 would mean you had 20 small sales in November at Mall 1. If we look at the 3, where is that at? So the 3 is right here. And we're thinking there's that column, this row. Put those together. It's our large sales in December at Mall 2. So you're just kind of picking apart what that number represents in each of the matrices. What about part B? By looking at the matrix, give the number of medium shirts sold at Mall 2 during December. So let's see. December, we're in this matrix. Mediums would be this column. And then Mall 2 would be this row. So where is that all overlap? Right here. So then you would have had 10. What are the dimensions of each of those? We do rows by columns, so it's a 2 by 3. And then what if we wanted to make the total sales? What do we do to each of those? We add them together. So we would take our November 20, 35, 17, 18, 29, and 14. Add them with our December sales, 16, 9, 13, 12, 10, and 3. When you add each of those up, you should get 36, 44, 30, 30, 39, and 17. If we're talking specifically Mall 1 and Mall 2, remember this first column was Mall 1, or the first row is Mall 1, second row is Mall 2. So we would want to add all of those numbers up to figure out Mall 1, and you get 110. And then we would want to total these up for Mall 2, and you get 86. So what sold the most? Mall 1. You had 110 shirts. We're going to go over part 3 at another time. Just hit me up with any questions.